All right, so anyway, comments. Okay, you already kind of talked about all this stuff. Now, I met these folks out in the lobby. They went to eat some food, and they missed out on all this stuff. I hope it was worth it. I hope that. Okay, that's good. You said it was or wasn't? It wasn't. Well, what could be worth this, right? I mean, that was a good answer. I don't want to hear that your Big Mac was worth my lecture. It's not a fast food lecture. It's a handmade lecture. All right, so I pretty much covered this, but just briefly, again, comets are made by ice rock and put on these very elliptical orbits. Now remember, according to Kepler's third law, actually Kepler's second law, the equal area law, these comets have to move a lot faster when they're close to the sun, because they have to sweep out equal areas in equal time. So if in a month out here, we have this much motion, that's actually sweeping out a lot of area relative to the sun, because there's a wedge there of area that gets swept out. Now, in that same month, we've got to sweep out just as much area when the comet is close to the sun, but now it has to go through a big arc in order to sweep out that much area. And so, of course, what this means is we have much faster motion close to the sun, right? So the flip side of that is comets spend most of their time way far away from the sun, where they're moving slowly. In order to sweep out equal areas in equal times at a large distance, you have to plod along very slowly. So they only have this sort of 15 minutes of fame every million years or so. When they flit by the sun, they melt enough to form the tail that we see. And in fact, actually, the comets fall into two major groups, the short and long period comets. The short period comets are ones that go out into our outer solar system, but only about as far as the orbit of Neptune and Pluto. So they have periods of orbit that are maybe 100 years or so. But then we have the long period comets that go much farther out, rather close to the next nearest star. And those have time periods of like 100,000 years. So that's why there's two major groups. And again, we'll talk about that more in detail when we get to chapter. Oh boy, the plugging is vulnerable. All right, now I don't even know what that means. I've heard about it. I've had to sign off on various risk factors, and I had to take out extra insurance. But I've never seen a plugin that was vulnerable before. Just quick play. They need therapy or something. Vulnerable. Let's see. Now see, it's so vulnerable, it won't even, it's probably shy. That's probably it. Wait, there it goes. Oh, here we go. I accept the risk. Don't show it again, even though I knew you will. Fine. All right, well, I've actually shown this before, but the main reason I'm showing it now is because I wanted to show what we call the Kuiper belt. Well, first, actually, let's show the asteroid belt. All right, so what we're seeing here is the orbit of Mars, dramatically speeded up, and there's the orbit of Jupiter, and the asteroid belt between Mars and Jupiter. That's that big jump by about a factor of 3 of distance going from Mars to Jupiter. There's a missing planet in there, and the missing planet is sort of where the asteroid belt is. The large gravitational effect of Jupiter caused these objects to fail to form into another planet. It was impossible because Jupiter's gravitational pull is so strong. It disrupted their ability to coalesce together. So instead we have the asteroids in the asteroid belt. But what actually was just talking about the comets, and I mentioned that there's two groups of comets. We have what we call the Kuiper belt, which is sort of a donut-shaped region around the orbit of Neptune or so. Here we see Neptune, okay? So that's Neptune right there. Out beyond the orbit of Neptune. This is just representative of this donut-shaped region of cometary nuclei, which are still in the part of the solar system where they formed. So they're like very primordial, uber primordial. What's the latest adjective young youngins use? I don't know. But mucho. It's kind of a retro thing. Mucho primordial. Very primordial. So that's actually, again, sort of a group of cometary nuclei. Now those guys out in the Kuiper belt don't have tails because they're so far out they didn't melt. They're not melting under the effect of solar radiation. In the inner solar system, the ones that get close form the tails. Notice the tail always points away from the sun. Even when it's moving away from the sun, the orbit, we still have the tail pointing away. Now, most of the comets are actually in a group that's much farther out than anything we can see here, much farther out than the Kuiper belt, which is called the Oort cloud, which is a large spherical cloud. that we'll talk about when we get to that chapter. But anyway, I want to say a few words about Voyager, because Voyager launched in the 70s with a sequence of 2 orbital missions with very large antennas, and they also have radioisotope generators. Okay, so radioisotope generators are otherwise known as kind of sort of a form of nuclear reactor. Now, not exactly reactors in the same sense of a nuclear reactor on Earth, but they're nuclear power systems. This is vintage 1980s, 1970s technology. And what's going on here is you have a bunch of radioactive, unstable material. And when you have material that's unstable to radioactive decay, it actually heats up due to this decay process. So it's a source of heat. And when you have a source of heat in the outer solar system, you can use that to generate electricity. So the electricity that's used is used to run the instruments here, which are measuring magnetic field and things like that in the outer solar system. Then we have a really big high-gain antenna. The reason for this really big antenna is because the whole point of Voyager was to go into the outer solar system. And when you're that far away from the sun, even if you're ET, you can't phone home unless you have a very large antenna on your cell phone. And you don't see antennas this size. This is about 6 meters across. Very few people are walking around with cell phones with an antenna 6 meters across clamped to it, because you don't need it. I'm sure you get a stronger signal, but who wants to drag around an antenna that large on your cell phone, right? So you don't need it on Earth, but in order to phone home from out there, you need a huge antenna, because we're talking about hundreds of millions of miles of distance from the sun. And then, by the way, that's also why we have to have this radioisotope generator for power. You notice there's no solar panels on this thing? Not solar power, because it went so far away from the sun, there's no solar power out there. It's got to power in a different way. All right, so back on Valentine's Day of 1990, Voyager looked back from the outer solar system and actually got a photo of all the other planets, because at that point it was actually out beyond all the planets except Pluto. And it was able to look back and see take a photo of Venus, Earth, Jupiter. Now, when you're that far away that Earth was that small, you know you're getting to the outer solar system. Even Jupiter and Neptune are pretty small objects looking back. Now, the reason I really wanted to mention Voyager 1 and 2 is because they're traveling extremely high speed. They're the fastest moving objects ever created by man, moving 3.6 astronomical units per year. Now, that's way, way below the speed of light, because you could do 3.6 astronomical units in only about a half hour at light speed, right? So these are going about 3.5 astronomical units per year, not just in 30 minutes. So, I mean, they're fast, but they're way, 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 way below the speed of light. But the interesting thing is that Voyager 1 has actually reached the edge of our solar system and passed through this region, which is basically where where the sun's magnetic field gives way to the interstellar magnetic field. So I just linked to an article here that documents the fact that Voyager 1 is actually the first man-made object to leave the solar system. So Voyager 1 leaves solar system as confirmed by NASA there. And this is actually just an artist's conception. Nobody's out there to take a photo like this, of course. But what this is supposed to be is kind of a dramatic depiction of the edge of the sun's magnetic field. Now, even though this article is actually dated September 12th, so only about a month ago, the actual passage out of the solar system was on August 26th. Let me zoom in on that because I know you're young and so kind of weak eyes. See? There, see? Actually left the solar system on August 25th, 2012. Now, it took them almost a year then, more than a year, to figure out that it left the solar system on August 25th, 2012. Well, this is pointed out in the article that they couldn't find any kind of mile marker or any sign that says, last rest area in the solar system, something like that. There's nothing like that. So the thing is, how do you really know that you left the solar system? Turns out there's lots of fluctuations taking place in the magnetic field out there. It's a little bit chaotic. So it actually takes a while, especially since this has never been done before, it takes a while to really know that you've made it through this, what we call the magnetopause here at the edge of the solar system, into interstellar space. So now, with this extra year, we've had to really analyze what's going on and these fluctuations, and we see things are now leveling off to basically not much chaotic variability in the magnetic field, but just a nice smooth behavior that is characteristic of the interstellar medium outside our solar system. So Voyager 1 is actually outside our solar system and still, incredibly, with a little tip of the hat of the vintage equipment, it's still working. It's still radioing back information from this incredible distance. Nobody ever actually expected it to survive this far. The Voyagers were actually meant to be missions to the outer solar system to study the planets, like Jupiter, Saturn, Neptune, etc. And then, just as the icing on the cake, they were sent into the way into the outer solar system to break through the void and get out of the solar system. Nobody actually thought they were going to make it, or that we'd still hear from them at this point. But they're still working, and that's the reason that we know that we're starting to learn about true interstellar space. So let's see, just to figure this out now. So they're moving about 3.6 astronomical units per year. They've just left our solar system. The next solar system is about 100,000 astronomical units away. So it's going to take like about 25,000 years for them to reach the next star. And when they do that, we're not going to hear from them. I mean, pretty soon we're going to get to the point where we can't detect their signal anymore because the signal is just going to get so weak from the distance. Yes? About the time we destroy ourselves? Well, it's hard to know when we're going to destroy ourselves. Yeah. Is that the latest estimate? 95,000 years? Okay, yeah, I just 25,000. Anyway, yeah, we may all be dead by then. Well, we'll probably be dead 25,000 years from now. Let's face that. Reality. But who knows whether we'll be alive at the rate. So the question was whether, an alien species could have already picked up the Voyagers, but then it's possible. They have this famous gold-plated, just a second. It has this famous gold-plated record with, characteristics, all sorts of things, scientific data, music from our planet, lots of Liberace and Elvis Presley and stuff like that. It's a bunch of the time, a little bit of Beethoven, a little bit of Beatles, not bad. But who knows what the aliens are going to think of that music, We actually included a diagram of how to make a phonographic needle. Because it wasn't a CD, it's an actual needle. You got to drop a needle onto the groove to get sound out of that. Let me see. I thought there was something else I was going to say that was more serious in reference to that. And it'll come back. So that's a good question. I mean, we don't know whether we're going to be alive. I know what I was going to say. But what happens in the movies is actually William Shatner finds it. Remember the Star Trek series? They actually find it out there, but it's like got a little bit messed up. It's called Beeger, the Voyager type. Drugged out. It's called Beeger, but they find it, and so alien life, not alien life, but intelligent life finds it, depending on your feelings about William Shatner. But anyway, I'm sorry, I put you on hold for a while there.